All right, welcome back.
Yeah.
Let's talk about data types.
Yeah, indeed. So you saw that we created some tables there, and we created tables that had columns of particular data types. Those data types can be different, obviously, types of data. So one type of data might be character strings, so where you've got text, effectively. So we could have fixed length character strings. A phone number is a good example where you might want to specify a fixed length. You could have variable length. We talked about variable length, so there's varchar and nvarchar types that we've seen. You've got large bodies of text, so maybe the equivalent of a document that you want to store. Technically, under the covers, it's stored slightly differently. It's not actually stored in the table. What you get in the table is a pointer to where that data is stored. But we can store large volumes of text. And we've got this idea of storing Unicode values. So where we've had varchar for variable length, we can have nvarchar for supporting character sets that aren't necessarily in the regular ASCII.
So anytime I've seen that N and an apostrophe in front of a data type or a string, that means it's that Unicode.
It's a Unicode value, yeah. And as well as strings, we can store numbers. So some of the numbers we've seen, you can store integers, whole numbers, in other words. And there are different sizes of integer. You can specify a tiny int, a small int, a large int. Don't worry too much about the details of the specific size limits, but you can be efficient in your storage by specifying the maximum size of integer you want to store.
But you also want to plan ahead.
You do want to plan ahead.
You want to think about what the largest number you might need to store is.
Yeah. We can store exact decimals, precise decimals to a specific precision and scale. And we can also store approximate decimals, so floating point decimals, where you might get the odd rounding error depending on how you calculate that. So you've got this option for storing these different types of numbers. We can store temporal values. So if we need to deal with dates and times, actually that's a really common thing in databases. So we can store dates, you can store times, and you can store date and time. So we've got the things like an order date at the precise point during the day when that order was placed. And we can even store things like offsets. So if we know that we've got a meeting time for an international calendar application, perhaps that we're building, we can offset it from, in this case, perhaps UTC. So you're offsetting it from the time in the Greenwich Mean Time in London.
About the birth date, that first birth date, 1971-03-07, is that March 7th or is that July 3rd?
So that is March 7th. I've specifically chosen a format that's a kind of recognized format because different countries do things differently. If you do it this way, you do the year, then the month, and the day, then two things happen. One is everybody can agree that that's the format. The other thing is that actually, if you were to sort that in alphabetical order, it's going to be in the right order because it's year, then month, and day.
Right.
And there are some other data types. There's more esoteric data types that you can store. So we've got things like bit for true-false values. We've got binary, where you can store the binary that's perhaps encoding a photograph or a video or something like that. There's something called a unique identifier, a GUID. Sometimes you'll see it called a global unique identifier we can store. We can store XML. We've got a data type that supports XML. We'll talk a little bit about one of the later modules. And similarly, we can store spatial data, so coordinates or shapes, geometrical shapes using spatial data. And then there's the idea of a timestamp. Timestamp's actually an integer value since sometime in the 70s. I can't remember exactly when it was, like 70 or something. But there's a specific date that's regularly used, quite often used in Unix systems as a timestamp. So the key points we've covered then, you're going to choose the most appropriate data type and size for your column. And you're going to have to think about the, as you say, the size eventually you might end up storing in there. So the biggest size you're going to need and the appropriate data type, whether it's a string or a number or whatever. You are also going to have data types. Some of them can be implicitly converted. So for example, if I tell SQL Server to do an operation that multiplies an integer by a decimal number, that'll quite happily work. They're both numbers. And if I tell it to insert a string that's actually consisting of numbers into a numerical column, that will work because SQL Server will say, well, you obviously meant that to be a number, I'll just convert it. But sometimes it won't be able to convert because it doesn't know what you mean. If you try and multiply a date by a string, that doesn't make any sense. So SQL Server will throw an error at that point.
And we can explicitly convert that using some built-in functions.
Exactly, yeah. There's functions in SQL Server to do that. Well, why don't I go and show you some examples of working with data types so we can see some of this in action.
Sounds good. Let's see a demo.
Well, here we are back in SQL Server Management Studio. And previously we saw how to create a table, and we're going to create another table now. And I just want to pay a little bit more attention to the data types of the columns in this table. So we're creating a table called dbo.accountmanagers. The first column is the employee ID that identifies each of my account manager employees, and that's an integer, so it's a whole number that I'm creating there. Then I've got a first name, which is a varchar, a variable length character is what varchar means. And because it's var and not nvarchar, what we're saying is this supports the ASCII character set, so that kind of standard set of English language characters that can be stored in that. Then we've got a last name column which supports nvarchar. So again, it's a variable length character, it's a string, but this time because of the n at the beginning, we're supporting Unicode or wide characters, so that more extended character set that supports some characters that might exist in languages other than English, so perhaps kanji characters or something like that. We've got the date of birth, which is a date. Now, there are various different ways of storing temporal values. You can have dates and date time, which would store the date and the time. This is specifically just the date for the date of birth. And we've got a salary which has a decimal value in here. So we're storing a decimal value in here that has 10 digits supported altogether with 2 decimal places. So it's going to be accurate to 2 decimal places with 10 digits. So let's go ahead and run that create table statement. And that creates my table. And we'll insert some values into the account manager. So I'm inserting into here Lucas Sondergaard, and you can see that there are some characters in here. These are actually regular ASCII characters, so it wouldn't matter if it was varchar or nvarchar, but just to make the point, we can insert different characters into here. And I've got my date in here, and look, the date is actually in quotes. I'm treating it like a string, so I've got 1971-03-07, which is the 1971. The next thing is the month, so that's March 7th, 1971. And the salary that I'm putting in there is 92,000. So let's go ahead and insert that. And that all works as expected. We get our row inserted into the table. Well, let's have a look at Rosie Reeves. We're going to insert Rosie Reeves into here. And this time the date format's slightly different. I've got 12/12/1988. So it's in a different format, but SQL Server will still recognize that as a date. And I've got my value here, which is a decimal, but I've left off the decimal places here, so it's just a whole number that I've put. So I've actually entered an integer, is really what I've done there, but it can be treated as a decimal. We just assume that it's 0.00 that's going to go on the end of that. So I go ahead and do that, and that inserts that quite happily. Well, here's another one. This time I'm going to try and insert Diana, and instead of a last name, I've actually put a number here. We're going to assume that Diana has a last name that's actually a number, 8411, and we'll see what happens if we try and insert that. And actually, that succeeds. So we've got this number here. You might have been expecting that to fail and throw an error, but it doesn't, because all that happens is SQL Server says, well, you've missed out the quotes, but I'm just going to treat that as a string. So I'm going to take in that as a string of characters. I can't do any calculations with it because it's not actually going to store a number in the table. It's going to store the string 8411. It'll treat it as an nvarchar in this case. So here's another thing. I'm going to insert into my account managers Aisha Witt, and I've got a date there. And notice that I've got the number here, the salary, but I've prefixed it with a dollar symbol. So I've actually put the symbol for the currency that I'm putting in there, and we might expect that to fail because that's not technically a number. I've put a bit of a character in there. But actually, it's quite happy with that. SQL Server recognizes that as being a symbol that goes with numbers, so it just treats it as a decimal number. Now let's try and get a little more creative. I'm going to insert into here Elwood McGee with a date, and this time I've specified the salary as a string with the dollar symbol. So I've put it in quotes, so it treats it like a varchar value there, and I've put the dollar symbol in there. Now so far it's accepted numbers where we should be storing strings. Let's see if it will accept a string where we want to store a number. And in this case it fails. It says I can't convert the data type varchar to numeric. So because we've got that as a string value in there, and we're trying to insert it into a numeric column, it's a decimal column, SQL Server at that point says, well, no, that doesn't fit into that column, so there's an error there. Well, let's try and be a little bit more clever. Let's try and insert it as a string, but this time we won't include the dollar symbol. So we've inserted it without the quotes with the dollar symbol, and that worked. We've tried to insert it with quotes and a dollar symbol, and that didn't work. If we had tried to insert a string value but we're only including numbers in that string, only numerals. We haven't got any symbols in there. Well, let's see what's going to happen. I'm just going to try and select that properly. There we go. And we'll run that. And that actually works. So again, SQL Server automatically does the conversion for me. It knows that this thing is meant to be a number. It has a look at what's in the string. It doesn't find anything odd. It doesn't find any strange symbols. So it just goes ahead and converts it. So sometimes you'll get perhaps slightly unexpected behavior when SQL Server automatically does these conversions of data types. And again, I'm going to insert into my value here. I'm going to insert Zachary Fellows. And the date format here is 30/7/1978. Now you can probably tell from my accent that where I come from, that's a perfectly valid date. That's the 30th of July 1978. But because my instance of SQL Server has been set up as if it were in the United States, it obeys all the rules for United States formatting for dates. And in the US, we do things the other way around. We have the month and then the day. So actually, I would have to change that to 7/30 in order to say the 30th of July. So there is some consideration that you have to make when it comes to how you format things like dates. It might be dependent on the region that your SQL Server is set up to support. And we'll just go ahead just to verify that all that data is now in there. If I go and bring back all of the rows from that table, I can see all of that data is in there. I can see that the dates are given to me in that standard sort of format here where you've got the year, then the month, and the day. That's the default that gets displayed when we bring that back. Now I could do things like try and bring back the employee ID plus the salary. You might remember previously we did a query where we concatenated some strings together. This time we're using the plus symbol, but we've got two numeric columns here. I've got an integer employee ID and a decimal salary. So the query itself is nonsensical. We're adding the employee ID to the salary, but it will actually work because these two things are numbers. So it can add two numbers together. If I use the same thing with first name and last name, where the two things are character data, they're not numbers, again it works, but this time the plus is used to do something different. It's used to concatenate, so it concatenates the first name to the last name. Well, what happens if I try and add the first name and the salary? This time one of these things is a character, one of these things is a number. So let's have a look at that. And this time we get an error. It doesn't concatenate it, it doesn't add it, we just get an error that says, hey, look, you've tried to do an operation involving a varchar and a numeric, and what it's trying actually to do is to treat it as an addition. It's saying, well, you know, I can't convert the data type varchar to numeric. You've tried to add a string to a number, and I'm not going to support that. I'm not going to allow that. What if I try date of birth to employee ID? Date of birth is a date, employee ID is an integer. Let's try that. And again, I get an operand type clash, slightly different error, but date is incompatible with int. Right, so these two things are not compatible data types. What if I try and add first name and date of birth? So this time a string and a date. And again, I get an error that says the types varchar and date are incompatible in the add operator. So it's trying to add them, and it's not able to do that because of those data types. So really what we've done here is we've just taken a look at some of the things just to be aware of when you're specifying the data types for the columns in your tables. Sometimes SQL Server will automatically convert between different data types if it makes sense to do so. Other times it might throw an error because you're trying to do something that's ambiguous, or it's incompatible to try and add strings and numbers or that type of thing. So be very aware when you choose the data types for your column that you choose an appropriate data type for the data that you're going to store there and for the operations that you're going to perform on it.
All right, welcome back. Let's talk about multiple tables.
Sure, yeah. So we've seen how we can work with one table. We've seen that working quite happily. Let's look at what happens when you've got multiple tables in the database and you need to query and work with more than one table. So we got our product table. We've been looking at this example all the way through, and here it is. And I've got that supplier column. The supplier is an integer value that identifies the supplier. And of course, really, that would be there'd be a separate table of suppliers. So we can create a table called supplier that has an integer ID as its primary key, and it has a name and a phone number. So we've got our supplier table there. And what we're trying to do is make sure that the values that go in our product table match suppliers that are in the supplier table. So when I insert into my supplier table some values there, I get my suppliers being quite happily added to there. you'll notice that I've got suppliers numbers 1, 2, and 3, and in my product table I've got existing products that are mapped to suppliers 1 and 2. So all is good in there, and that's all fine, that works. What I want to do is I want to make sure that I can't insert a product with an invalid supplier. So I'm going to alter my product table, and I'm going to add a constraint. And this time the constraint is something called a foreign key constraint. And what it's doing is it's saying the supplier column in this table is the foreign key that references the primary key in another table. It references the primary key in the supplier table. So whatever goes in this supplier column in this product table must match a value that's already in the supplier table.
Now, if you run this and you've got existing data in the product table, and some of that doesn't have a matching supplier number, what happens?
Well, I can specify an override. I can specify whether I want to apply it to existing data and throw an error or just ignore existing data. So I actually get the option when I do that. What typically you might do is you might allow nulls, so that you've got a kind of a workaround to say, hey, there's a null value in here. Now, what I'm then going to do is I'm going to insert some values into my product table. So I insert a new product, a doodah, and it's 199, and it's from supplier number 3. It's from A datum. And that's perfectly valid. I've got supplier number 3, that's great. Now if I try and insert something else in there, I'm going to insert a MacGuffin, and I'm going to reference supplier number 5, but I'm going to get an error because there is no supplier number 5. So I get an error thrown for that. So we're applying what we call referential integrity.
So do the other columns values get stored? Do we get a new row with MacGuffin in 299 and it just leaves out the 5?
It doesn't. We'll talk a little bit about transactions later on, but each time we insert just an individual statement, it's what we call an implicit transaction. SQL Server makes sure either the whole row gets inserted or nothing gets inserted. So if anything fails, nothing gets inserted. So let's look at the key points we've covered there then. Most databases, I think we saw the example of normalization at the beginning, most databases will have multiple tables as a direct result of that. And we use keys to determine the relationships between those tables. So a primary key uniquely identifies a row in an individual table, and you might use a foreign key that relates to the primary key in another table. So we can make that relationship between the two. And we can use foreign key constraints to enforce those rows, to prevent invalid data sections. And we prevent deletions as well in updates. So for example, what would happen if I had a supplier and I had products that came from that supplier and then I deleted the supplier? Well, that would leave some orphan products.
Right.
So I want to prevent that.
Sure.
That whole thing is generally referred to as referential integrity, the integrity between the references between tables.
Right. All right, well, let's see what this stuff looks like. Let's have a demo.
Sure. Well, you might remember in a previous demo, we created a table called customer, and we created another table called account managers. So if I go and refresh my list of tables here, you can see there's my customer table and there's my account managers table. And the idea is that each account manager is responsible for managing one or more customers. So each customer will have an account manager assigned to them, is another way of thinking of that. So what I'm going to do is I'm going to add a column to my customer table that tells me which account manager is the account manager for that customer. And I'm going to do it by adding an integer value. You might remember if we look in the account managers table, here's a little shortcut for you. If I right click account managers here, I can go and select the top 1,000 rows just easily out of that. So we'll go and do that. And it goes and generates the appropriate SQL for me. So I can see here the account managers I've got, and each account manager is identified by a unique employee ID. So I've got an integer value here that identifies each account manager. So what I'm going to do in my customers table, again, we'll just do the same thing with customer. Let's have a quick look at that. Each customer is also identified by an integer ID, but that's neither here nor there. There's nothing in this table that specifically says which account manager is associated with the customer. So we need to add a column to this table, basically. So we're going to do that by using this alter table statement. We're altering the table. We're adding a column called account manager, which is an integer. So it's going to be the integer value that is the employee ID of the account manager that this customer is managed by. And I've added this value here. First of all, I'm saying that I'm going to allow null, so I'll allow the case where a customer doesn't have an employee ID, an account manager associated with them. But when they do have, it will reference the account managers table employee ID column. So in other words, the value that goes in here should match an employee ID that's in the account managers table. So let's go and run that. And off it goes and happily completes that. And if I have another look at my customers table, we'll just go and run that select top 1,000 rows again. I've now got my account manager column. That's been added to the table, but the values are all null just now because I haven't inserted any customer ID values into there. Well, let's go in and do that. We'll update the customer table and we'll set the account manager for all of my customers to 1. So whoever account manager number 1 is, they're going to be the account manager for all of the customers. And we'll just again go and verify that that's actually happened. So let's have a look. Yep, sure enough, account manager is set to 1. And what I'm going to do is I'm going to add a new customer. So I've got a brand new customer in here. This is Rhonda Hughes. I'm adding her. And I'm specifying it when I insert the table. This last column here is the account manager column, and I'm specifying that this one has account manager number 2. So if I go ahead and do that, sure enough, we've got 1 row affected. We've inserted that table in there. And if I go and look at my customer table here, sure enough, Rhonda Hughes is in there with account manager number 2. And if I look at my account managers table, we can even find out who that actually is. Employee number 2 is Rosie Reeves. So we know that Rosie Reeves is the account manager for Rhonda Hughes. All right, well, so far so good. What happens if I try to insert a new customer with a non-existent account manager? So we don't have an account manager. We don't have anybody with employee ID number 9, but we'll try and insert that into there. And actually that fails. We get an error that says the insert statement conflicted with the foreign key constraint. Remember when I altered the table, I specified that this has to reference the account manager's table employee ID column. That created this thing called a foreign key constraint. So the foreign key is the key in the customers table that references the primary key in the account manager's table. And it says it conflicted with that foreign key constraint, and it occurred in that database, and the column was the employee ID column. So we've tried to insert a customer with an account manager that doesn't exist in the account manager's table. That is not allowed because of that constraint, so the statement is terminated and the customer is not inserted. So what we're really doing here is we're using foreign key constraints in order to enforce what we call referential integrity between the tables in my database. Where I've got a value in one table that references a row in another table, we have referential integrity enforced here because of the constraints that prevents me from putting in a value in the first table that references something that doesn't exist in the second table.
So what have we learned?
Well, that's a good question. Let's take a look at the slide and see what we've covered in this module. We actually covered quite a lot. We talked about using the create table statement to create tables. So we've seen how to do that. We've seen how to use the insert statement to add rows. We'll talk more about inserting and working with data later on, but we've seen the basics of inserting rows and using the select statement to get rows back out of the table. And we've talked about the idea of using constraints that define the relationships between primary keys in one table and a foreign key in that table that references a primary key in another table, and that enforces referential integrity between those tables.